Hello and welcome everyone. My name is Srikanth Sopirala and I'm a Principal Analytics and AI Solutions Architect. Today, we are going to discuss one of the most critical topics in modern data architecture. How do we effectively govern and manage data stored in data lakes? Effective data governance is key to ensure the integrity and trustworthiness of an organization's data assets. We will cover why data lakes are important to organizations, AWS's approach to data governance, and various AWS services that can help with governing data lakes, and also walk through a couple of demos to deep dive into these services. Let's dig in. Data lakes are the new information hub. They are centralized, secure repositories that enable you to govern, discover, share, and analyze structured and unstructured data at any scale using the tool of your choice. They power your analytics, machine learning, business intelligence, and data warehouses. Amazon S3 is the best place to build a data lake because it has unmatched durability, availability, and scalability. More than 700,000 data lakes are built on Amazon S3. It has the best security, compliance, and audit capabilities, the fastest performance at the lowest cost. Amazon S3 also has the most ways to bring the data in and the most partner integrations. It is built to store and retrieve any amount of data with unmatched availability. Customers execute trillions of requests daily on S3 data lakes. Governing data lakes is one of the key initiatives for many of our customers, and it is complex. That is why we came up with an approach for data governance on AWS. Effective data governance requires capabilities in curating, understanding, and protecting your data. Curating data involves organizing, transforming, and linking the data to improve quality. This includes master data management, data integration, and data quality management. Understanding your data involves providing descriptive information about the meaning, the sources, the transformations, and other characteristics of the data. This includes data profiling, data cataloging, and tracking data lineage. Protecting data involves ensuring proper access, retention, security, compliance with regulations, and management of the data lifecycle. So the purpose of the data governance is to enable end users, data scientists, and other application developers of all kinds to find, access, and share data. And once found, the data should be in a condition to be useful for business purposes. And we want to keep the data secure, comply with relevant regulations and policies, while also making it as easy as possible for authorized end users to access the data they need. Governing data lakes provides guardrails to innovate faster. So to understand how to implement data governance on data lakes, let's consider two personas. The technical users like data engineers, data scientists, and the business-focused personas like business analysts. Each of these personas are focused on certain areas in the data governance framework. For example, the technical users are more interested in file formats, partitions, data quality, data location, data security, while the business users are more interested in business glossaries, data sharing, data marketplace, business justification, data classification, and data stewardship. Let's consider a use case where a data engineer and data steward are trying to make the data more useful for business decision makers. They also need to make sure any sensitive data contained within the dataset is identified and masked. This is required for regulatory and compliance reasons before the data can be made available for the data consumers. They're also trying to identify and recommend data quality requirements of the data. AWS has many services that can help with this use case. Let's take a look at them. Understanding data is an important aspect of governance, and that is where AWS Glue Data Catalog and AWS Glue can help. AWS Glue Catalog is an open, performant, and scalable technical metastore on top of data lakes. It has unmatched durability, availability, and scalability. And it is serverless, cost-effective, and integrated with many AWS and third-party analytical services. AWS Glue has many capabilities to understand, unify, and curate the data like data profiling, identifying sensitive data, and data quality. Let's take a look at a demo to understand, unify, and curate the data in the data lake. In this demo, let's take a look at how AWS services like Amazon S3, AWS Glue Catalog, and AWS Glue can be used to govern the data in the data lake. Here, we are using Amazon S3 for our data lake. And then in buckets, we have a bucket where we are storing our data in an S3 bucket. And then we have multiple data sets here: customers, policy, and claims data. And then each of those data sets are stored in a CSV file. It can also be stored in a Parquet file. Now let's take a look at how we can crawl the data and then gather technical metadata of this data lake using AWS Glue Catalog. Technical users like data engineers want to understand the data in the S3 data lake. So they can use services like AWS Glue Data Catalog to capture the technical metadata by crawling the datasets in the data lake. Let's take a look at that. In this example, we created a database called Customer Database, and then we have a table called Customers, and we have used a AWS Glue crawler to crawl the data in the customer database for the customers tables. Now you can see that it has captured a technical metadata for the customers tables in the Glue catalog. For example, you can see that there is a location of this and the input format, and it also in the database of customer DB. And also you can see that it inferred the schema for all the column names and the data types respectively. Now, to better understand the customer data, we are going to use AWS Glue Data Brew to profile the data and identify the PII data from the customer data. So let's take a look at that. So using Glue Data Brew, we will import the customer data into Data Brew and create a data set. Once you create a data set, we will create a job, which is basically a profile job and then a customer profile job. Let's look at the details of the customer profile job. As you can see in this customer profile job, we are going to output the profile output into a data lake back again. And then in the dataset level configurations, we are identifying the PII columns. So we are setting the PII statistics to enable the PII statistics in the profile job. So when you run the job, you can identify the PII dataset from the customer's data. So now let's take a look at the profile statistics that we completed. So if you look at the data profile for the customer data, as you can see, it gives you a summary of the total rows, number of columns, data types, the missing cells, duplicate rows, and correlations, and comparing the value distributions and also the column summary. As we talked about, to understand the data a little better, we also asked the data profile job to identify the PII columns. In here, you can see that the profile job is identified, for example, the C_name, C street address, city, email address, credit card number as the PII columns. And then it also identifies the potential PII data like gender, birth date, and C state. Now that we have identified the PII columns, let's use AWS Glue Visual ETL to write a Glue job to mask the data that is being identified as PII columns by the AWS Data Brew. So in here, we have created a job using the Visual ETL. And then if you see the transform for the detect PII, we are identifying the email address and credit card to redact the data. And then by using a certain redaction text, and then write it back to our data lake in Amazon S3. So far, we have profiled the customer data, and then we have also identified the PII data using an AWS Glue job. Now in here, let's see how we can apply data quality rules using AWS Glue ETL job. So in here, we have created using a Visual ETL, we have created a ETL job to evaluate the data quality of the customers table. So let's look at some of the parameters here. So in here, we are evaluating the data quality with a certain rules. We have provided certain rules, and we want to check the data quality of this data set. And then based on the data quality, the rule outcomes, we will output that data into our target S3 bucket, which is our data lake. And then also, if there are any data quality rules that fail or pass based on the conditional routing, we will put them back into the data lake, into the data catalog, so that we can see them and evaluate that data as pass and fail records. So let's take a look at the job details of the data quality job. So as you can see, the data quality job has been completed successfully. Now we can look at the data quality output of the data quality job. So as you can see, each of those rules is a data quality job. Glue ETL will go through all of those rules that we have asked to check, and then it validates whether the rule has been passed or not. So if there is a rule failure where the column value names week of the month claimed is less than equal to 5, the rule is failed. So it will capture that failed rules, and then we can take that data and put that back into a table or into a database where then you can evaluate that data and then either fix the data or recreate that data set. So far, we have seen in terms of the governing a data lake, the three fundamental things in terms of understanding the data, curating the data by profiling, by identifying the sensitive data, and also by applying the quality rules for the data set in your data lake. Now that we have seen how you can store, curate, unify, and understand the data in the lake, now let's consider a use case where data engineers are producing data products. Data stewards are creating and managing a data marketplace, and data analysts need to consume the data and analyze the data. In essence, they are looking for an easy way to build a business glossary, an ability to discover data and share data to analyze. And this is where Amazon Data Zone fits in. Amazon Data Zone is a data management service that enables you to catalog, discover, govern, share, and analyze your data. With Amazon Data Zone, you can share and access your data across accounts and supported regions. Amazon Data Zone simplifies your experience across AWS services, including but not limited to Amazon Redshift, Amazon Athena, AWS Glue, and AWS Lake Formation. Using Amazon Data Zone, you can discover and share data at scale across organizational boundaries with governance and access controls. Amazon Data Zone makes data accessible to everyone in the organization. Now let's take a look at the demo of Amazon Data Zone on how you can publish datasets and subscribe datasets by consumers. Let's take a look at Data Zone and see how we can create a data marketplace to publish and subscribe datasets from a data lake. So in this, we have created a domain called corporate domain, and then you can also associate certain accounts, and we have associated the account, and you can associate multiple accounts across regions and across various accounts. Let's go to the Amazon Data Portal and let's see some of the components of Data Zone. As part of the Data Zone, we created 3 projects, which is claims, marketing, and underwriting. And each of those projects, we have associated a data lake environment. We have created an environment and created a profile, and then also a data source, which is from the S3 data lake that we saw in the beginning. And then we inventoried the claims data using that. And then we published this claims data using created AI descriptions. So let's take a look at the marketing data, where you can see that if you go to the data here, and then you can look at the published data sets. We don't have any published data sets. So let's look at the inventory of the data, and then let's use customer redacted table. And then you can generate descriptions by using AI recommendations for descriptions in Amazon Data Zone. And then also you can publish an asset. So let's publish an asset, redacted data, so we can view that data or we can subscribe that. The other key component of the Amazon Data Zone in terms of managing the data governance on data lakes is creating a business catalog. So business glossary is basically a collection of business terms that may be associated with data sets. Let's take a look at how to create a business glossary. So in here, we are in the claims project, and let's look at the data and then go to business glossaries. As you can see, there is no glossary. So let's go and create a business glossary with a name called confidentiality. And then also provide a description, define the level of data confidentiality, and then let's go create the glossary. Now we can go and create the terms in the business glossary confidentiality by clicking term. So let's click create term, and then let's enter the term confidential. We can leave the description as optional, and then let's create the term. Let's create another term called public and restricted. Now let's apply these business glossary to the underwriting project and add a glossary to the policies dataset. So let's go to the underwriting project. Let's go to the data, and then let's look at our published dataset, which is basically policies. And then here we can add terms. So let's add the terms. If you click on this, you will see that these are the terms that we created in that business glossary: restricted, public, and confidential. So let's add confidential to the terms. So now you can see the glossary terms, the policies data is confidential. So far we have seen that a data steward using Amazon Data Zone can successfully create a data asset, publish the data asset, and additionally enrich the data catalog with business glossary metadata. So now we have published a data set, created a business glossary. Let's see how we can subscribe the data set from the published asset. So we logged in as a business analyst into the marketing project. So let's go to the claims project and let's subscribe to the data for the marketing project, and then let's give a reason for a request so the data steward can see that and approve that subscription. So let's subscribe. Let's go to the claims project, and then as a data steward, we go to the claims project, and then if we look at the data and then the incoming requests, you can see that there is a request that has been requested by the business analyst user, and then we can see the reason why they want to access this data. So let's go ahead and put a comment in here and approve it. Now let's log in back into the business analyst, and we can see that the subscription has been approved. The business analyst can use Athena to query the data and run analytics on the claims datasets. Now that we have seen how to share, govern data in a data lake and create a data marketplace, let's jump into the final use case around the third pillar in the data governance, protect. When it comes to protecting the data, most organizations are looking for simplified permissions model, fine-grained access control to their data, comprehensive auditing, and the data permissions at scale. AWS Lake Formation makes it easier to centrally govern, secure, and globally share data for analytics and machine learning. Lake Formation simplifies the data lake permission management by introducing DB-style fine-grained permissions model on data catalog resources. These permissions apply across the data lake stack. This means that Lake Formation manages access to the S3 buckets and objects where the data associated with the data catalog resources resides. These permissions also work with a wide variety of analytics and ML engines. Many enterprise customers ask for the ability to map their well-established corporate identities to their data in their S3 data lakes. Amazon S3 Access Grants allows you to map corporate identity users and groups from Okta, IAM, and Entra, the service formerly known as Azure AD, to S3. Additionally, S3 Access Grants log the end user identity as well as the application used to access Amazon S3 data in AWS CloudTrail. This helps provide a detailed audit history for all access to the data in your S3 buckets. You can combine S3 Access Grants with Lake Formation. Lake Formation can be used to govern access to cataloged, structured, and tabular data, whereas S3 Access Grants can be used to govern access to uncatalogued, unstructured, and non-tabular data. So let's look at the use cases for S3 Access Grants and Lake Formation. With S3 Access Grants, the permissions based on layout, such as prefixes in S3, can be used. And with the Lake Formation, the permissions based on schema, such as rows and columns of a table, can be used. Now, let's look at AWS Lake Formation on how to manage find and access control to make data accessible for a table called employees in a HR database. As you can see in the Athena console, where you can query the data, you can see the employees table has ID, first name, last name, date of birth, annual salary, department, and region. Using Lake Formation, we can control the column level access and the row level access for this table employees. Let's jump into Lake Formation. In the Lake Formation console, let's go to the data lake permissions. And from there, we can grant the analyst role, the catalog resources from the database HR for the table employees. And that let's do a select table permissions. And then let's pick the column-based access where we can exclude that annual salary. And then let's grant. Now, let's also do a row level access for a northern region HR representatives. So let's create a data filter. Let's go to data filters. And in here, let's create a new filter. In the new filter, the filter name, let's create as the North region. And then choose a database, which is the HR database. And then the target table is employees. In the column level access, we have access to all the columns. In the row level, let's create a row level access. And let's add a row filter expression where region equals to North. And let's create the data filter. So let's select the newly created data filter and grant permissions for the HR rep regional North role, for the database HR and the table employees for the North region. In the data filter permission, let's choose select and then grant. As we have seen how we can control table level and column level and row level access using lake formation, we can also see that you could use S3 access grant to scale the permissions for semi-structured and unstructured data. So S3 access grants, as we talked about previously, you can create an S3 access grant instance. You can register the S3 buckets or prefixes as locations, and you can create grants. So for example, you can see that I've created an instance for the S3 access grants with an identity center as the on here. And then I've created a couple of grants where one is for the prefix and customers, and then the other one is for the bucket. So lake formation and S3 access grants allow you to control access permissions for structured and unstructured data for a data lake. In this video, you have seen how AWS services like AWS Glue, AWS Lake Formation, Amazon S3 Access Grants, and Amazon Data Zone can help with data governance on data lakes. Thank you.